Okay, again on the test, all we have to do is supply the reasons for these. So number 36, y is the interior, and then we have measure of angle 3 plus measure of angle 4 equals measure of angle ABC. Okay, so what's happening here? These are angles. Number 36 is the angle addition postulate. Okay, anytime you have interior and you're adding angles afterwards, it's angle addition. Number 37 is a little bit trickier, but things are repeated here. We have measure of angle 3, measure of angle 3. We also have measure of angle 4. Okay, we're replacing the 4, 50 in for the 4. So I'm putting the 50 in here, and I'm putting the 40 in here. That is called substitution, because 40 plus 50 equals the 90, and that's where that came from. So the answer for 37, the reason for that one, is substitution. Moving on to 38. How do we know that 90 is measure of angle ABC? How do we know that that's right? The reason why is its definition of a right angle. And then 39, if they're both right, how do we know they're congruent? All right angles congruent. Let's see that proof. Second problem, we have number 40. We have the word bisects in here, so you know bisects has to be one of the reasons for number 40. Okay, now is it a segment bisector or is it an angle bisector? In this problem, it's bisecting a segment. So we're going to say this is a segment bisector. Definition of segment bisector. I'm going to abbreviate. Number 41. Okay, we have a word that's going to help us in the proofs. The word is midpoint. How do we know that a midpoint makes two parts congruent? Because I know what the word midpoint means. I'm going to say the definition of midpoint tells me how I can go from one point of the problem to the other. Okay, number 42. How can I go from congruent to equal? Well, I know what congruent means. So I'm going to say definition of congruent. 43. This one's a little bit trickier. I have AB equal to BC, BC equal to CD. I'm going to add AB plus BC equal BC plus CD. Because I'm adding, like I said, we're going to use addition. The addition property. Okay, 44, we have the word between. How do we know that between means I could add up the two parts? If B is between A and C, then we know that AB plus BC equals the whole thing. This is one of our definitions. Definition of betweenness. Number 45. Okay, now we have AC equals BC. Now for this one, what's happening here is we have two of the same again. We know that BC plus CD, and here we have AB plus BC, AB plus BC, so I'm substituting what's left, AC and BD. This is a substitution. And the last one, 46. How do I go from equal to congruent? Just like I went back here from congruent to equal. Same reason here. Either way I go, congruent to equal or equal to congruent is the same reason. It's definition of congruency. Okay, and the last one before we do one on our own. Up to 53. So 47. 47, we have an interior, we have angles added up to each other. 47, we did this one before already. If for inside, then we can say angle 1 plus angle 2 equals this angle ABE. That's angle addition. 48. 48. This one's a little bit trickier. Okay, again I have the same thing twice here. Measure of ABE, measure of ABE. What's happening here is I'm substituting this part in for one of the ABEs. Okay, 1 and 2 and 3. We already know one measure of 3 is there, and we have it equal to measure of angle ABC. So this is substitution. $49. Okay, we have a word in there that's going to tell us what the definition is. Definition of bisects. But we can't just say bisects, we have to be specific. This is a segment bisector or angle bisector. Well, it's bisecting an angle, so it's an angle bisector. On to number 50. Angle 1 is congruent to angle 2. Measure of angle 1 equals measure of angle 2. Again, another definition of congruency. 51. If we have measure of angle 1 is equal to measure of angle 2, measure of angle 1 equals 35, we can substitute. 35 equals measure of angle 2. $52. Now we have 70 equals measure of angle 3, which equals 110. Alright, where did they get that from? Looking at measure of angle 1 is 35. We know measure angle 2 is 35. So what they're doing is substituting. Measure of angle 1, measure of angle 1, and we have measure of angle 2, measure of angle 2. Okay, that's where they're getting the 70 from. So this is another substitution. And the last one, 53, we have measure of angle 3 equals, I want to say this should be 40. Okay, and the last one is subtraction. So this is going to be substitution, because we're substituting the 40 in for the measure of angle 3, and we end up getting 110 degrees. Alright, last but not least, we're going to try to prove this theorem by yourself. Alright, so we have the givens. We're going to go ahead and write those down. Okay, we know that measure of angle 1, 2, and 3 equal 180 degrees. We know the measure of angle 2, angle 2 is a right angle. And we know that the measure of angle 1 is 25. Well, if we know the measure of angle 2 is right angle, we know that the measure of angle 2 is 90 degrees. Okay, and that's going to be our first reason. Okay, we also know that the measure of angle 1 is 25, and that's also given. So, we are going to use substitution and kind of put the 25 in for measure of angle 1, the 90 in for measure of angle 2, and then we can figure out what the measure of angle 3 is from there. So, I'm going to group this. And basically, I don't have to write this down, but what's happening in the problem is 90 plus 25 plus measure of angle 3 equals 180. Okay? Which means measure of angle 3 is 65. So I now know that the measure of angle 3 is 65 because of this right here. So my first reason is definition of a right angle. And I know measure of angle 3 is 65 is because I'm plugging this in. 90 plus 25 is 115. Subtract the 115 over, and that's how I get the 65. Now if you wanted, you could show an extra step and show how that is actually resubstituting in. So then you have step 2 and step 3 for substitution. but you can skip steps there. And that's the proof.